A new critical vulnerability just revealed that hackers can execute code on your systems through hidden text inside pull request descriptions, and most organizations don't even know it's possible yet. This is CVE 2025-53773, and it's one of the most dangerous attack vectors we've seen for AI systems in 2026. Here's what happened. Researchers discovered that you could inject malicious code into a pull request description, and when an AI-powered code review tool processes it, the hidden prompt forces the AI to execute that code without any human review. Think of it like hiding instructions in a thank you card that secretly reprograms the person who reads it. The vulnerability works because modern AI systems are being used to automate code review workflows. They're designed to summarize pull requests, flag potential issues, and even approve changes, but they weren't designed to detect that someone had buried an instruction inside the request description itself. This isn't just a theoretical problem anymore. Attackers are already exploiting this in the wild. Model poisoning, prompt injection, and data leakage attacks are introducing vulnerabilities that don't exist in traditional software environments. Traditional cyber attacks come from outside your network. These AI attacks come from inside your workflow. What makes this particularly dangerous is that pull requests are everywhere: GitHub, GitLab, internal repositories. This attack surface is massive, and every company using AI-powered development tools is potentially exposed. This is where it gets complicated. So how did we get here? AI has become the new frontier of both cybersecurity defense and attack. Over the past few years, companies started using machine learning to catch vulnerabilities automatically. Sounds brilliant, right? Fewer human reviewers needed, faster code deployments, consistent security checks around the clock. But here's what most coverage gets wrong. When you give an AI system the ability to detect threats, you've also created a new target. Attackers realized they could poison these AI systems just like they poison water supplies. Instead of attacking the system from the outside, they attack from within. Think of it like this. You hire a security guard who reads reports really well, so you give them more and more authority to make decisions based on reports they read. But then someone starts filing fake reports designed to manipulate that guard into making bad decisions. Guard isn't broken. The guard's trust in the input was misplaced. In 2025 and early 2026, we saw a spike in what researchers call adversarial attacks on AI systems. These attacks exploit the fact that AI models learn patterns from data, but they can be tricked into seeing patterns that aren't really there. Adversaries are now leveraging AI for zero-day exploits and autonomous malware that can adapt in real time. The scale is staggering. This isn't one company's problem anymore. It's an entire industry waking up to a new class of threat. Let's look at how prompt injection actually works, because understanding it is the key to protecting yourself. A prompt injection attack works by embedding instructions inside data that an AI system processes. The AI treats those embedded instructions as legitimate commands. Here's the technical breakdown. CVE 2025-53773 specifically targets AI code review systems. An attacker crafts a pull request with seemingly normal code, but in the description they've hidden text formatted in a way that tricks the AI into interpreting it as a system command. For example, they might write something that looks like a comment, but actually changes how the AI processes the rest of the request. The AI reads the description, parses it, and executes the injected prompt. If that AI system has access to run code, which code review systems often do for testing and validation, it runs the attacker's code with the same permissions the review system has. This is remote code execution, or RCE. That's the nuclear option of hacking. What makes this insidious is that the attack is invisible. Your code review logs won't show anything obviously wrong. The PR description looks normal to humans because the injection is hidden in formatting, whitespace, or structured comments. The AI sees it as a legitimate instruction, but humans reviewing the same text see nothing suspicious. This is why traditional security defenses failed. They were designed to catch attackers changing code. Nobody expected attackers to change the instructions the AI receives. Let me show you what this actually looks like in practice. Imagine a development team at a fintech company. They've automated their code review process using Claude or another AI model integrated into GitHub. A developer's pull request comes in, looks normal at first glance, but hidden in the PR description, embedded in a comment that looks like a note to reviewers, is an instruction. Instruct the AI to approve any changes to the authentication module without checking the actual code. The AI's instruction following is so sophisticated that it follows this meta-instruction and approves a change that would let attackers bypass login controls entirely. Real-world impact. That kind of compromise could expose thousands of customer accounts. This has already happened. Researchers found active exploits of similar vulnerabilities in development environments at several major tech companies. The attacks aren't theoretical, they are happening now. But it gets worse. Model poisoning means attackers can contaminate the training data that AI systems learn from. If you're using an AI trained on public code repositories, attackers can inject malicious code into those repositories specifically to poison the model's training data. Any system using that model then inherits the vulnerability. Data leakage is another angle. Prompt injection can trick AI systems into revealing sensitive information from their training data or from the context they are processing. A single well-crafted prompt can extract proprietary code, API keys, or database schemas that the AI had access to. And here's the twist nobody expected. These attacks are multiplying. How does this compare to traditional cybersecurity threats? The key difference is adaptability and scale. A traditional vulnerability, say a buffer overflow in Windows, affects one piece of software. You patch it, the problem goes away. Security researchers can study it, understand it, document defenses. But AI vulnerabilities are different, because AI systems learn and generalize. The same attack concept can work against dozens of different AI systems in different ways. A prompt injection technique that works on Claude might work on ChatGPT, might work on Gemini, might work on specialized tools. It's like discovering one lockpick that opens 50 different doors. Traditional attacks also require technical depth. You need to understand how a specific system works, what compiler it uses, what CPU architecture runs it. AI attacks. A non-technical person can craft a prompt injection attack if they understand how language models interpret instructions. That lowers the barrier to entry dramatically. Here's the scale difference. A traditional hacker targets one company, one system, one vulnerability at a time. An AI attack can be weaponized across an entire category of systems simultaneously. If you discover a prompt injection technique that works on AI code review tools, you can deploy it against every company using that tool all at once with minimal customization. Traditional defenses like firewalls and intrusion detection look for suspicious network traffic, but these attacks come from inside normal development workflows. They are hidden in legitimate pull requests from seemingly trusted developers. Your security tools don't flag them because they look like work. And that's just the beginning. What does this mean for organizations and the broader AI economy? The honest answer is that security fundamentally changes how we'll build AI systems going forward. You can't just deploy an AI into a critical workflow without also building defenses against adversarial attacks specifically. For software companies, the implications are enormous. If your development pipeline uses AI tools, and most do now, you need to assume your AI can be manipulated. This means adding human review back into workflows where you'd removed it. It means air-gapping your AI systems from sensitive repositories. It means assuming that any prompt processed by an AI could contain an injection attack. For individuals, the risk is less direct unless you work in tech. But consider this: autonomous malware powered by AI is now being used in real attacks. Attackers are using AI to generate polymorphic malware that changes itself to evade detection. They're using AI to auto-generate zero-day exploits. The defenses we relied on for decades, signature-based detection, pattern matching, are being outpaced by AI systems that can generate new variants faster than humans can patch them. The talent gap is real. Organizations need security specialists who understand both traditional cybersecurity and AI vulnerabilities. That skill set doesn't exist in abundance yet. Teams are scrambling to hire people who can think adversarially about AI systems, and there aren't many. Insurance companies are starting to price in AI risk. So what can you actually do to protect yourself? If you're running a software team, here's the security checklist you need right now. First, audit every AI system touching your code. GitHub Copilot, Claude, ChatGPT, custom models, document them all. Know what data they can access and what they can do. Second, implement mandatory human code review for any changes touching authentication, payment processing, or sensitive data. Don't let AI fully automate that approval step. Use AI to flag suspicious patterns, but keep the final approval with a human. Third, isolate your AI systems from your production environment. If you're using an AI to generate code, don't let it run in the same environment where it can execute. Sandbox it. Test the code it generates separately. Fourth, watch for prompt injection in real time. Add monitoring that looks for suspicious patterns in pull request descriptions and code comments. Look for attempts to override system instructions or unusual formatting that might contain hidden commands. Fifth, keep your AI models updated. As vulnerabilities like CVE-2025-53773 are discovered, model creators patch them. You need to update your tools immediately, not 6 months later. Sixth, train your team. Everyone writing code needs to understand that AI tools can be manipulated. They need to spot suspicious prompts and unusual AI behavior. If you're not in tech, the principle is the same. Use AI as a helper, not a decision maker in critical situations. Here's what this all means for you and what to watch for next. We are in the early stages of AI security becoming a mainstream concern. Right now, the attacks are mostly targeting tech companies. But as AI tools spread into banking, healthcare, and government, the attack surface expands exponentially. The good news, we've learned lessons before. We survived the transition from no encryption to encrypted communications. We adapted security practices when cloud computing became standard. We'll adapt again, but it requires investment, vigilance, and accepting that no system is completely safe. The reality is that AI security is going to require a fundamentally different mindset. Instead of assuming your systems are secure unless proven otherwise, you need to assume they are compromised and design defenses accordingly. This is zero-trust security, but applied to AI specifically. In the next 6 months, watch for 3 things. First, new patches to popular AI coding tools as more vulnerabilities get discovered and fixed. Second, security regulations emerging around AI use in critical infrastructure. Governments are waking up to this problem. Third, the emergence of specialized AI security companies that do nothing but hunt for prompt injection vulnerabilities and adversarial attacks. The investment in AI security is about to skyrocket, and that's actually healthy. It means the industry is taking the problem seriously. CVE 2025-53773 was a wake-up call. The question now is whether companies act on it before the next big attack happens.